Hi and welcome to the first section of our course on data analysis with Python. This section is about Python core concepts. Let's have an introduction to the section. We'll have an overview of the basic syntax for Python and we'll discuss the built-in data types. You will have a better understanding of iterables, list comprehensions, and functional programming concepts. Dates and times are also particularly useful and deserve a separate mention. Finally, since this course is about data analysis, we'll discuss how to access raw data. The first video is about Python core concepts and data types. We're going to discuss the built-in data types, comparisons and truth values, the definition of custom functions, and finally some control flow statements. So we're going to start with a brief introduction of some Python core concepts and built-in data types. For this session, we're going to use Jupyter Notebook as interactive Python environment. With this interactive environment, you can edit your code online and observe the results, so it's a very convenient tool for tasks such as exploratory analysis. If you want to run the code in the active cell, you can use the GUI, or simply hit Shift and Enter. The first cell has some variable declarations. Some particular value is here assigned to the variables myname, x, and y. The interpreter is stateful, so once you run a cell, the variable and function declarations are part of the state for the following cells. For example, you can access a previously declared variable using the print function. The built-in function type returns the type of an object, so we can observe that myname is a string and x is an integer. The built-in function isInstance checks whether an object is of a particular type. For example, you can see that myname is a string and myname is not an integer. Something useful to keep in mind is that in Python every data type is also an object. Now let's discuss more details about data types. First, the Boolean data type. Boolean values can only be either true or false. The type signature for Booleans is simply bool. Booleans are tied to the notion of comparisons where a particular condition is evaluated to a Boolean. For example, given the two variables that we have declared previously, we can compare whether the value is equal or different. It's also useful to remember that Boolean values dynamically behave as integers. In particular, true is equal to 1 and false is equal to 0. For numeric comparisons, we can use the symbols less than or greater than. For example, 1 is less than 2. Also, 1 is less than or equal to 2. This second comparison is useful to test the edge cases. We can combine multiple conditions using the keywords AND and OR. In this example, we are saying that 1 is less than 2 and 2 is less than 3. The last cell shows a more compact way to write the same condition. We can now move on and describe the numeric values in Python. There are three numeric values: integers, floats, and complex numbers. In this example, x is an integer and y is a float. For the complex numbers, we have a real part and an imaginary part. The imaginary part is defined by appending the letter j. Alternatively, you can use the complex function. You can observe the type signature for the numeric types that we have just described. So x is an integer, y is a float, and z is a complex number. You can perform arithmetic operations between integers and floats, and the result will be a float. So x plus y is 7, and x times y is 10, and both numbers are floats. Now strings. Strings are used to handle text data. Strings in Python 3 are containers of Unicode characters. You have a few options to declare a Python string, using single quotes, double quotes, or triple quotes. Strings declared using triple quotes can span multiple lines. In this example, the values for these four variables are all the same. String formatting is an interesting operation. The last declaration of the variable language uses curly brackets to present a placeholder. The format function we replace it with the value of PyVersion. Now you can observe the actual value for the variable language. and also the type signature for the string type. Strings are essentially sequences of characters, so you can access a specific character using the index. In this example, we print the first character using the index 0, because Python is 0 indexed. String objects have a bunch of useful built-in methods for string manipulation. For example, we have functions to convert a string to lowercase or to uppercase. The replace function tries to match all the occurrences of a substring and replace it to a new one. All these functions return a new string, so the original variable is not changed. The next types we're going to discuss are lists and tuples. Lists are defined using square brackets and are normally used as a collection of homogeneous items. Tuples are defined using round brackets and are normally used as a collection of heterogeneous data. For both lists and tuples, we can check whether an item belongs to the sequence, so Red is in my list and John is not in my tuple. Also, both lists and tuples are iterables, so they can be used in a for loop. There is much more about lists and tuples, so we'll pick up this topic in more details in a later video. The last built-in data type we discuss in this video is the dictionary. Dictionaries are used to map keys to values and can represent complex heterogeneous objects. In this example, we define a dictionary item using curly brackets. This dictionary has 4 keys: ID, price, description, and in stock. You can also see the type signature for dictionaries. With a dictionary, you can access the value of a particular key, in this example the price. You can also override the value of a given key simply by doing another assignment. Keys can also be removed from a dictionary using the del keyword, and new keys can be added to a dictionary also using a simple assignment. Finally, if we try to access a key that does not exist, the interpreter will raise a key error exception, like so. Next, let's consider the definition of custom functions. The def keyword introduces a function definition. It must be followed by a function name and a list of arguments between parentheses. The body of the function starts on the next line, and its statements must be indented. In this example, the function name is Adam, and the arguments are a and b. The body of the function simply returns the value of a plus b. Once the function is declared, we can call it to return the sum of the two numbers. Because of Python's dynamic nature, there is no explicit data type declaration on what kind of arguments we need to pass to the function. If we pass 2 strings to the same function, it will return their concatenation. If you mix the argument types, for example a string and a number, the interpreter doesn't know how to perform the operation and we raise an error, like so. Finally, let's have a look at some basic control flow statements. The most common statement is the if statement, which can be used for conditional execution. The if statement will test the truth value of a condition and execute the relevant branch of code if the condition is valid. In this example, a and b are both greater than 0, so the first condition is met and the first branch will be executed. The elif keyword is short for else if. This allows to add new optional conditions to check in case the first one is not met. You can add any number of elif branches. If all the conditions evaluate to false, the else branch will be executed. The else branch is also optional. You can pause the video for a moment and try to change the values of a and b to better understand how to work with if-else statement. While statements are used to repeat a block of code while the condition is still true. In this example, we count down from 5 to 0. Once the value of x is smaller than 1, the condition is not true anymore, so the loop will stop. For statements are used to loop through an iterable. Iterables include objects like lists and tuples that we have just discussed. Strings are also sequences, so you can iterate over each character. Now we conclude this video with a simple exercise to recap some Python core concepts. You can pause the video now, try to solve the exercise, and check the solution later. Now we have a list of products, and each product is represented by a dictionary with name and price. So what we need to do here, we need to loop through all the products and check whether the price is higher than 10. If the condition is met, we simply print out the name of the item. And we should end up with simply an orange. In this video we have discussed some core concepts for Python, in particular some of the built-in data types, how to perform comparisons, how to define custom functions, and how to use the basic control flow statements. The next video is about understanding iterables.